¿Listo, cierto?
Sí.
Yeah. Today we going to be very short, not very short, like maybe it's a very little class. Okay. And yesterday we discussed about so many processes, right? Last week we discussed about so many classes related to like top-down method, like physical method, chemical method, this kind of things, right? Today we're going to be discuss about biological process. I think 1 minute. Yep. Yeah. And today we're going to discuss more about like biological process, how this biological process useful. Okay. Remember these biological process related to the top up methods. Okay. And right, last time we discussed like how we can call like a top-down method, bottom-up method, right? From the bulk material to they form nanostructures, right? And from the atom to they form bottom-up method. From the atom to they form nanostructures, right? And physical method we applied like physical everything like physical process. Here we use like chemical process. Remember, today we are discussing only the biological methods. Here, see, this is the biological method. This is like biological method is comes like two kind of biological methods. But to understand, I will explain very simple things. Okay. Here we are using the plant, right? This is a plant. Generally, plant what will happen? You see this plants have like seed, roots, stems, leaves, flowers, fruits, fields, these kind of things, right? Any part from the fruit, if you take any parts, okay, then these fruits related materials we're going to be used for synthesis of nanoparticles. And same thing here, like biological process, biological methods. We take like living systems, like fungi, bacteria, Easter, like alga related things. We use synthesis of nanoparticles. Here, in the earlier we know, right, like a precipitation method. In the precipitation method, we use all the chemicals, right? Like in the precipitation method, what we're going to use, like we use the raw materials and just we had initiators and we make like some precipitations, right? To understand clearly, first of all, forget about everything. Just we can see that biological process we call green synthesis process. Okay. Here, why we call green synthesis process? Generally in the chemical process, we use all toxic chemicals to reduction of the nanoparticles. Here we not use any lot of toxic materials. We use like own natural materials, like water kind of materials. They not be too much toxic for the environmental and for the humans also. That's why we called green synthesis process. The two green synthesis process classified like two parts. One is photo-assisted biosynthesis process, and second one is biogenic nanoparticle synthesis process. This one is plant-related, right? This one we called photo-assisted biosynthesis process. All this comes like photosynthesis, like from the sun, they can build themselves, right? This comes from, that's why they called photo-assisted synthesis process. Here we use only plant-related materials, only natural plants, okay? And here we use like bio-related materials, like these kind of materials we're going to be use. That's why it's called biogenic nanoparticles in this process. These two process, green process. We can come here, see here the plant, all the planters. What we will do generally, we take plant materials. We will like suppose how we can make the green tea. We take some tea powder, right? Just we put into the hot water. Just we boil little few minutes, right? then we'll think the green tea is ready, right? Same like that. What we can do here, we take the plant materials, we boil into the water, and after that, when you boil, what will happen from the plant, like carbohydrates, polyphenols, like any kind of any kind of like organic materials, they will come into the water. And this one, when you add into the when you add into the like synthesis of nanoparticle reaction, these these molecules, this molecule have like OH functional groups, they have like COH functional groups, and some of them have like ammonia functional groups. And this one, they start to reaction with metal solution nanoparticles. Then they form. Then when you had like when you have like pH adjust, when you do little pH adjustment, the nanoparticle will form here. Okay, and generally, one more time. Yeah. What we'll do generally, yeah, the most simple in the precipitation method, what we'll take, we will take any kind of metal solutions. Here, we're going to be take any metal solution. For example, if we take like silver chloride, AgCl, AgCl, when you keep into the water, what will happen? It will happen like Ag plus, Ag minus, right? They form like two different ions. When you add these molecules here, what will happen? Then from here, they're going to be get some charges and they form like Ag0 nanoparticles. They form like nanoparticles, fully convert from ions to they convert fully as a nanoparticles. And here, when you have like calcium chloride, it will act as like calcium oxide nanoparticles. The plant materials, they involved in the reactions, and finally they form the nanoparticles. If you see here, happen, it's not happening. 1 minute. Yeah. Here, the plant kind of any materials, we also like plant extractions, what kind of these kind of things we also call like secondary metabolism materials. These secondary metabolism materials act as a reducing agent due to their functionality like OH functionality, COH functionality, ammonia, like any kind of functionality, functionality mainly like this one, like OH functionality, they can react with these nanoparticles. These ions, they finally form like Ag0 nanoparticles. This is just example, okay? And the same thing, what will happen doing like in the biogenic synthesis process, like biogenic synthesis process, also we do same, and we extract whatever we're going to be extract, and we're going to be add here, and it will involve in the reactions. To understand more, we can discuss again. You can see here, generally people, they take like any leaves, any seeds, any garlic leaves, whatever these kind of things, they will make some powder. Okay. Then this powder, they're going to be boiled. Like suppose why they make powder? Suppose this kind of plants, this kind of things, not available in the all the year. Sometimes it will avail like some fruits will come some seasons, some plant will grow sometimes, some flowers will come sometimes, right? Like each pot they're going to be dry. They will bring and they will make the dry. After drying, they make powder. The powder they will take like 1 gram, 1 gram in 100 ml, maybe like 1 gram in 200 ml. They make exactly they're going to be take. and they're going to be make these solutions. These solutions, this solution we should fix. Why? Suppose if you here we know if we for synthesis of nanoparticle, we think 1 gram is enough. 1 gram is powder is enough. Sometimes we thought that if in nanoparticle form, we think no, 2 grams we needed. Suppose when you 2 grams also not needed, we're going to be fixed like 3 grams is good for to make. Like so example, like how can I say? Like each people, like when you make coffee, okay, when you make coffee or tea, suppose some people they need like more strong coffee. Some people want like very less coffee. It's like that. Same thing, like synthesis of nanoparticle, we need sufficient group of functional groups. Like that, we're going to be use how much we need this powder. We're going to be mixed into the water and we can extract the liquids. Then we're going to be use the synthesis of various kind of nanoparticles. Okay, this process generally we use in the photo assisted synthesis process. Okay, and we also use directly. We can also take plant from plant leaves directly, and also we can use it directly also. But it will be it will be not be more accurate. If you make like powder is so good. If you use natural one also is so good, but we don't know how much phenolic, how much like concentration of materials we are using directly for the synthesis of nanoparticles. That's why all the people they make powders. After that, they're going to be use the powders. Okay, but in my case, I will use the directly like directly mint leaves without drying. But I will use like 8 grams, 7 grams. I will make some optimizations. Yeah. And now we're going to discuss about the biogenic nanoparticle synthesis process. Yeah. Now we're going to discuss about biogenic synthesis process to understand very clearly. Generally, what we'll do in the like growing of normal cells or maybe do antibacterial activities. Generally, what we'll do, just we do follow some analysis, right? Like we can take some tube and we put like some media, right? We're going to put media and after that we add bacteria here. So after that we use like whatever we analyze. This is for 37 degrees, right? 37 degrees we can keep to grow the bacteria. Then after that, what we'll do, we will extract. Suppose we will extract the liquid. We'll keep the liquid inside, or maybe we'll add other media to grow the cells. Like we are doing this kind of things in the laboratory level, right? So here, what we'll do, the liquid, whatever we make this liquid, we will remove the bacteria here. Sorry, it's not going back. Oh, oh, oh. Yeah. What we'll do, this liquid, you can see this liquid. This liquid, we have to make sure we have to remove this bacteria from this. Okay. After removing this bacteria, this liquid we directly use for the synthesis of nanoparticles, particles like this field. Okay. Why? Sometimes, see, suppose this bacteria, like E. coli bacteria, might be any other bacteria, is dangerous for us, right? So we have to make sure how we can remove, and we also do like UV radiation forces, like we can apply like UV radiations. Then this liquid we're going to be used to the reduction of the nanoparticles. Here, what is the problem for us? Like suppose when you're growing the like bacteria any cells, what will happen? While they have like when they are growing time, they release different kind of oxygens, right? Like different kind of species they're going to be released into the liquid medium. The liquid medium have different kind of functional groups. Like they have COH functional groups, they have thiol functional groups. This kind of functional groups, they're responsible to reducing of the nanoparticles. Generally, we can call this biogenic, like biological synthesis process. This is everything like enzyme related one. Okay. This one like plant-based one, like might be fungus, like might be bacteria. This kind of the solutions we are going to be use the synthesis of the nanoparticle here. See, biological sources, everything from the biological sources, like with the plant, extracted, mushrooms, seaweeds, fungi, algas, bacteria, we can use all these kind of things. Okay. And we take same like any kind of metal solutions we can take and we can add here and they're going to be reduce the nanoparticle size and finally we get like different morphologies. But like each one is more different. Okay. And remember in the this when you growing time, like we can in the liquids, this liquid solutions, they have like sulfate, ammonia group, and they have COH kind of groups. They can able to reduce the nanoparticle size. Okay. The simple, more simple, what I want to say, whenever we grow bacteria like this, like we have water here. Suppose we leave a few days, what will happen? The fungus will grow here, right? The fungus will grow. Then we can remove the fungus by doing a centrifugation. This water we can use directly to synthesis of the nanoparticles. Why? There are still they have the bacteria when growing bacteria, they release some active feces inside the water. The active pieces will responsible for the reduction of the nanoparticles. This is more simple. Okay. And and also this somebody they use like this kind of processes, they use like a hybrid synthesis, hybrid synthesis also. We can to understand more clearly here. I given like two examples here. For the first one, example, chitosan. We have chitosan and cerium oxide. Okay. And here they remove the cells after growing they grow like cells here and they remove the cells. And this one they added here. Okay. When you added, what will happen? They have some reaction each other. Like they form like the cerium oxide, they form like Ce plus M plus something like the chitosan plus metal solution. They have so many reactions inside, and finally they form like CuO2. Chitosan, the cerium oxide, like cerium hydroxide, they reduced as like O2. Why is happening here? Because of this liquid, because of this bacterial liquid, they converted as a like nanoparticle solution. Okay, same phenomena is applying here. Like whatever we use like fungus, like biogenic materials, we can use reduction of the nanoparticles. Okay, this enzymic materials also we can use for the synthesis of the nanoparticles. And to understand here, like little clearly, like photogenic synthesis process, this is a biogenic process. Also, we can call the microgenic synthesis process also. Okay, and see here, photosynthesis process. They have main functional group, OH functional groups, C double bond groups, that kind of groups will be there. The biogenic synthesis process, while growing up like in the tube, when you growing up the cells, okay, these cells, they can release this kind of functional group into the medium. Okay. This kind of like thiol group, ammonium group, this different ammonium groups, they're going to be useful for synthesis of the nanoparticles. And also we can say like the molecule, like stabilizing the capping agent. this kind of like whatever, like proteins, like any kind of this polysaccharide related materials, like from the plant extract. Sometimes they use like capping agent, like nanoparticle. They will be like in the top, like capping agent. And sometimes they use like stabilizing, like they can be the structures long period. Okay, they can useful like stabilizing agent as well as capping agent also. The key is like to understand more clearly, they have like this functional group regularly will be have OH, C double bond O, COH, ammonia functional groups. Generally in the photogenic synthesis, they involve in the synthesis of nanoparticles. Okay, and here thiol, amine, carboxyl, and sulfhydryl groups, they gain more. They're going to be involved in the synthesis of the nanoparticles. This is only to, I think when you read more, we will understand more about these things. Okay. ¿Algunas preguntas? Yeah, digamos.
Nanoparticles is are a state fundamental or extra oxides? No, see, no. For example, carbonyl. Never. Or no?
Carbonyl? No, this group, this carbonyl group is not nanoparticle, it's functional group of plant. Okay. This
Mhm,
one, they make reaction with, suppose if you have like AgCl
mhm,
plus, sorry, Cl minus,
mhm,
it will share electron for this, okay, and it will convert as a Ag0.
mhm.
If you have more these groups, they can okay for synthesis of nanoparticle. If you know this group, there might be any group. If you know I have these groups, the nanoparticle is not synthesized.
Ah, okay.
Okay, and here also
Thank
same
you.
like a bacterial liquid. The bacterial liquid have like a more thiol group. This one also useful for synthesis of nanoparticle. If they don't have these functional groups, we can't get the nanoparticles. Understand? Yeah. And one more thing. Suppose here, 1 minute. So yeah. See here, while synthesis of nanoparticle, this is a liquid, okay? This is a metal ion. Here we added all this one. We're going to be add here. I don't know. It's coming. Yeah. This is a this is a metallic solution, okay? And this is a liquid, like this is a extracted plant materials, okay? This one we can use as a reducing agent. This can reduce the nanoparticles very small, okay? Sometimes here we have to, in this process, okay, we have to optimize like pH, temperature, and also like reaction time. Like if you have more strong, the reaction time is very fast. You have more functional group like OH or OH functional groups, maybe they have more COH group, the reaction will come very, very fast. If they have very less functional groups, this one, the reaction time will be increased. So sometimes what will happen when you do the reaction, we can make heat here, we can make heat, or we can adjust the pH. This pH we have to adjust. Remember all the time, when you synthesis of nanoparticle from here to here, when this reaction liquid, the pH should be 7 to maybe like 13, 14 if you there. we will get the nanoparticle. The pH is very less, we can't get the nanoparticles. Okay, we have to remember this one. Any reaction when you synthesize of nanoparticle, the pH almost like 7 to 13 or 7 also be there. Is we can form the nanoparticle. If you have less pH, they not form nanoparticle very faster. Okay, we can adjust this pH by using of any kind of solvents like acids or sodium like bases we can use to synthesis. Yeah, this is more important for us to comparison how these process are good or not, which process we can use. This is more important for us. Okay, but all remember all the processes have the advantages, all the processes have the advantages. Okay, and first one is cost wise, like photosynthesis and biogenic synthesis process. Okay, the cost wise, this is a low cost. Why low cost? Just we going to be take the plant from the outside, right? So that's why this is low, less cost. And this one is high cost. Why? The growing of the bacteria, growing of the cells, we need a lot of chemicals, right? And we have to need a lot of liquids. So that's why this is little more costly than photosynthesis method. And scalability, this is a little difficult. Why? The plant not available in the all the time, right? Maybe the some plants will be like we have 12 years, right? Which maybe it will available in only few years. So that's why the people are make powders to use synthesis of this process. This one, say here, the scalability we can use anytime, right? Like if you have like good chambers, good bacterial lab, we can grow the cells or bacteria in all the time in our laboratory. But only thing is expensive. Like environmental impact, this is a natural one, right? Natural products, leaves. There's no toxic. This is little toxic. This is why this is a biological waste. And also like we don't know like some bacteria, if you some bacteria which stand still, which stand in the bottle, it will problem for us, right? So we have to make sure to the removal of the bacteria cells. And like process control, this is very difficult, but this is easy. Like because no we know that how much cells we can able to grow in the well, like 100 ml of water, 200 of 1 ml of water, like that. That's why this is so good. And this is a reaction. This is very slow. This is very faster. And here, if you increase the concentration level, it will also be very faster. And safety, this is a low toxicity. This is high toxicity. And finally, like nanoparticle here, the controlling of the size and shape is little complicated. But here we can control the nanoparticle. Like if you want like the round shape, we can control. We can also be control like we can prepare like 2 to 10 nanometer size also. And medical applications, we can use like almost all the medical applications. Mainly we can use for drug delivery, any therapeutic application we can use. And this one is not recommended to use in the medical applications due to the microorganisms. Maybe if you grow the normal cells liquid, maybe we can use for the synthesis of nanoparticle without any complications. Okay. If we grow like virus, cancer related liquids, we can't use for the synthesis of nanoparticle because of hazardness. Okay. If you grow like normal cells like skin cells, melamine cells, that kind of things, that liquid we can able to use for the synthesis of the nanoparticles. And same thing, and last time, okay, yeah, same thing we can see here, metal synthesis. Um, Sorry, we can go for the again back. Okay, now we know, right? Almost we completed how we can synthesis of this nanoparticle. We synthesize by top to down method, right? Like from the bulk material to small materials. And these methods we called, what we call these methods also? physical process, right? Physical synthesis process also we can call. Here, bottom up method, we can prepare nanoparticle from small to high. No, sorry. From the liquid to we can prepare the nanoparticle, right? In the bottom two, we can prepare like up approach. And these are the chemical process, right? This is a chemical process. This is also chemical process. This is also chemical process, but they classified like a green synthesis process. And green synthesis process we classify like plant related one and microorganism related one. And see now is this is a clear. I think this is a clear right to how we can synthesis of the particle. Is clear or no? Any questions?
Sí.
Oh, okay, okay, that's nice. See here. So now these processes we can apply for like any kind of like medicines related one. We can also apply this one for the energy related things. We also applied for any agriculture related things also. This process, by using of this process, the people will start to prepare the nanoparticle, what they want, which process is better due to the cost wise. We have to calculate and we can use. And most of the things, the people we can able to use this plant one for the medical applications to improve the nanoparticle, to decrease the cytotoxicity of the nanoparticles. Okay, and here see like in generally the agriculture people like agriculture any parts like we can use any parts to synthesis of the nanoparticle by using of various kind of applications like like tissue engineering, agriculture, environmental science, like industry things we can able to use like any kind of agriculture waste, any kind of agriculture waste we can able to use synthesis of the nanoparticle for respective applications. Whatever we use like chemical synthesis, physical synthesis, biological synthesis, what is our ultimate goal? We have to get very small size of nanoparticle in order to use for the medical applications. Okay. And whatever we can use like chemical, biological, everything only to get a good, good kind of nanoparticles. And now we have to forget about all things. Okay. Now we are going to be discuss very small things to the updated one. Okay. This is a different kind of synthesis process. Same this one, but I'm explaining like little differently. Okay. Synthesis of nanoparticle. This they called also the different methods. This is they call like initiate synthesis process, execute synthesis process. This is not difficult to understand and very easy to understand. And now we can discuss first one, what is initiate synthesis. Okay, let's discuss about this one. Yeah, here we can see these are raw materials, starting materials. Okay, here we use this is the salt. Okay, TiO2 sol means they take like a titanium oxide related salt. They're going to be adding to the monomer. Okay, they're adding like some solvents and they mix together here. Okay, and they mixing together and after that they do the polymerization process. In the polymerization process, what happened? The polymer matrix they form in the top and this nanoparticle is prepared inside the hydrogen network. Okay. Here, what, for example, what if you take here silver chloride, AgCl, okay. Here they convert as Ag plus. Okay. When you add like polymerization process time, what will happen? This is formed like Ag0. When you heat, maybe this particle form like here very big, maybe here very big, maybe here form very small. Okay, what happening here? The nanoparticle form inside the polymer matrix, like any kind of matrix. So that's why we called in-shoot synthesis process. Understand, right? Here, whatever we take anything, just we mix together and we added like here, polymerization process started in family form in the nanoparticle matrix. This we called nanocomposite. We can keep whatever other names. For example, here we did some work. We did some work. What will happen? This is a polymer matrix, like they called acrylamide and carbopol polymers. And they added like silver salt. This is a silver, and this is a gold salt. The silver salt and the gold salt. Here they add mentha extractions, like right, mentha liquid, like plant liquid to synthesis of Az0 nanoparticle. Here synthesis of gold nanoparticle, and here they mix together like silver nitrate and gold one. They mix together. They added mentha reducing agent. The nanoparticle form inside like a different format. Why the people adding like two materials compared to single material? Dual material shows good antimicrobial activity. That's why the people are always use like two, three metals to synthesis of one kind of nanoparticle to better like biocidal activity. They show good anti-cancer activity. They show good in infection control activities also, like antibacterial like that kind of things. The here what I want to say, the nanoparticle, where they form the nanoparticle, they form inside the matrix, right? Inside the matrix they form. That's why we called in-shoot synthesis process. So another one, exit synthesis process. How the nanoparticle is formed? Here what we do, we take directly nanoparticle. We take directly nanoparticle and we mix with monomer and whatever the photoclass tinker, just we mix and we add initiators. Just nanoparticle is formed. Here, nanoparticle we use directly. In the backside, we synthesize the nanoparticle inside the matrix. Understand, right? Clear, right? Listo? Lo listo. Any doubts? No? Okay. Maybe if you have any doubts, just remember, okay? Just difference here, we take nanoparticle directly, we mix with polymer, monomer, all the things, and it will form final product. In another case, we take the salts, we mix together, and they form inside the matrix. Then we call composites. Both are composites, but the forming of nanoparticle, mixing of one is more different. Okay. Suppose when you go the yeah, what how can I say examples? No examples. Okay. 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 Mm. Mm. Yeah. Anything doubt? Mhm. Yeah. We're going to discuss one more. See here from the here we don't want to be understand very good. Just we need to understand what is in-situ synthesis process, what is exit synthesis process. Okay, and here there is so many classification in-situ methods, execute method, in-situ method. There is so many processes. Everything we already discussed, like co-precipitation, sol gel, thermal, everything we already discussed, but they keep different name, chemical evaporation deposition method, we already everything discussed, but there is different names they kept here, okay? And more importantly, we have to know about grafting methods, and this is no needed, but we can discuss like a electrostatical deposition method. Okay, now we can discuss. No need to be get more information, but we need to get this grafting information. Okay, we already discussed about Folgel methods, right, in the previously, and also micro emulsions. This kind of we already discussed, but sonochemical method, polyprocessing. This is a different one, but we can discuss this one and two, three process we can discuss now. Okay, this is in-situ synthesis process, right? Like execute synthesis process. But don't we can forget about that. Just we can see here what happening here. We are discussing now graft form technique. Okay. Here what they're going to do. This is the salt. They use salt like a gold salt. They mix like stabilizers, reducing agents. It will form like this. After that, they add initiator. The initiator come and attach here, like here. And after that, they're going to be add monomers and polymers. They grow like here. So this kind of techniques were they called graft forming technology. And there is also they have like graft 2 technology. They take same like gold salt and polymers. They take directly here. They take monomer. They take here polymer directly. They add reducing agents. In the nanoparticle surrounding, the polymers is going to be surrounded. These kind of techniques they called graft 2 technology. The from will convert like related for the monomers. 2 is related for the 2 is related for the directly to the polymers. Okay. And final one is post modification. This one, this one related to this one exude synthesis process. Okay. Here what they do, they took the polymer directly, they take nanoparticle directly, they mix only. They mix only, they can use for medical applications. They not do anything new, just they mix all the two, one or two materials, then directly they start to use. Why the people are mixing like the polymers here? You know the nanoparticle have more toxic than polymers. To reducing of the toxicity level, they use the polymer to coat on the top of the polymers. This one we can use for the our medical work. Okay, and this one like electrode deposition method. This one we no needed to know much, but we can discuss one time. Okay, here we can see that like positive, no, positive and negative electrode cathodes. Okay, they keep like two like anode and cathode they keep like here and here, and here they keep like whatever we want to do coating, we can take this directly, we can fix here one and two like this. And suppose this liquid inside the liquid they have graphite. And also they have nickel. Okay. When you supply some energy for that, what will happen? All the nanoparticle go on, they deposit it on the top of the materials. And these materials we can use for implementation, like inside our human bodies, we can implement, we can keep inside, and we can use for replacement of any bones. Okay. And also these kind of things they use for different energy applications also. We can see here, this is not coated any nanoparticle. After coating of nanoparticle, it will be comes like different color. And when you do the same, when you do the morphology analysis, we can find like this very small, but when you see the morphology analysis, we can find nanoparticle are deposited on the top of or not. This is just to know that we never use this kind of process much. All who are working in more medical areas, we never use, but to understand this one. And this one, reverse mycelium analysis. Here, this to understand very easily. Maybe this kind of practice we can do in our laboratory in the practical time. We can do here. Okay. Here, what they do, like they take any polymer solutions, like here any they can take any kind of polymer solutions. We can mix nanoparticle salt. Okay, then we can add reducing agent. When you load the nanoparticle inside, when you add reducing agent, the nanoparticle will form very smaller. Okay, then when you dry, it will form like this. And when you see in the morphology analysis, we can find like the nanoparticle, the top, the polymer going to be attached. And what happened from the here, there is a liquid. When you dry, it will form like very small nanoparticles. Okay. And this one also we can in our laboratory we can check this one. Then you will understand more about this. And the class is almost is over. Okay, just we can see here whatever we discussed, all the methods, all methods also related for this. Generally, we take polymer and we disperse with the nanoparticle. This polymers we can use directly, and by using of this method, we can synthesis of polymer nanoparticles. And also we can take monomers and we can mix some drugs, whatever we want to mix some drugs. And also we can use all this process synthesis of the polymer nanoparticles. Like we can use without drugs, without metals, all similar process. We can use synthesis of the polymer nanoparticles. Okay, like we can use like peptide nanoparticle. We can also use like protein related nanoparticles by using a similar process. So what will happen? This one we're going to be studying the next class. Okay, now just I am going to be explain here. Generally, what we do, we synthesize like we using all any kind of process. What we'll do, we will synthesize these nanoparticles, right? After synthesis of nanoparticle, what we have to do? We can't use directly for the medical applications. So what we have to study? We have to study some important characterizations for that. Why we have to study? The nanoparticle have more toxic, or they form very good or not. And these things we can analyze by some using of special techniques. For example, we can use this morphology analysis. This morphology analysis, like how the nanoparticle form very small or not, we're going to be discussing in the next classes. Okay. And here we can see the DLS and zeta potential. And suppose when nanoparticle is formed, like how much charge it have, like they have positive charge or they have minus charge. Suppose when you have like a nanoparticle have good positive charge, good negative charge, we can be able to use for the medical applications. And suppose here 30 minus 0, 30 plus. Suppose if you have 0, the nanoparticle have 0 charge, we can't use for the medical applications. Okay. If you have like up to 30, up to 30 plus, we can able to use for the medical application. And what happen if you more than this, we have to take care of these kind of nanoparticles because they have more toxic for the normal cells or cancer cells. So we have to coat specific molecule on the top to use in medical application. This one we can study by using of DLS analysis. We're going to be do practice in our laboratory in the practical time of this one, okay? And also like we can also be study their characterizations. Suppose when you use like any drugs, any kind of molecules, we can going to do like the FTR, XRD, DS analysis, X-space analysis. We're going to be studying the laboratory level, but we can't study all these things. We don't have a lot of time, so we can study like FTR analysis. We're going to be study in the laboratory, and we're going to study like DLS and zeta potential studies in our laboratory. And this one you guys know, right? In vitro evaluation studies, you guys knows. And after these two things, we know that nanoparticle form very small or big or is not good. We know confirm that one. Okay. Once we confirm what we'll do, we want to use for in vitro applications. In vitro applications, if the nanoparticle have less cytotoxicity, then what we have to do, we go for using of nest in vivo evaluation applications. And these things more important to go for the in vivo applications. Once we done in vivo applications, we start to use on humans trial. We can use for any big animal models. Also, we can able to use these nanoparticles. Okay, we have to keep in remember one synthesis of the nanoparticle. We have to study their solid state characterizations and morphology characterizations. Then we go for the in vitro studies. Once we confirm the nanoparticle have non-toxic, and sometimes we know that we also need like how much concentration we need to kill the cancer cells or maybe like antibacterial. We're going to be study in vitro releasing studies. Then after that, we're going to be used in vivo applications. This is the process we need to be follow for any kind of applications. Okay, and up to now, what we seen, what we learn, up to now we learn how why nanoparticle needed, right? And their physical properties and chemical properties, biological properties, and how we can synthesize by using a bottom-up method, top-down method. And in the bottom-up method, we learn about like chemical process, biological process, right? And biological process we studied today only, and after that we studying now. In the future class, we're going to be study how this nanoparticle we can identify, how we can identify their toxicity level, and also after that we're going to be go for the mechanism, how this nanoparticle mechanism involved in the cancer, and